Let's just jump right into it. Have you ever wondered why so many engineering degrees completely miss reality? Today, we're unpacking a deeply personal story that, honestly, hits the nail on the head. It perfectly captures that massive, canyon-sized gap between just checking boxes on a university syllabus and, actually understanding the real world. We'll be exploring this through the lens of an engineer named Gobal Krishnan V, because his journey uncovers exactly why this educational gap even exists in the first place. Okay, let's dive right into this. Before we really get into Gabal's journey, I want you to just take a second and reflect on your own education. Really think about it. Did your degree actually teach you how to build things, how to create, how to truly understand? Or did it just teach you how to pass an exam? I want you to step into Gabal's shoes for a second. Literally, millions of students walk into universities every single year, and they're faced with this exact same underlying reality, often without even realizing it until, well, years down the line. So picture this. It's 2012. Gobal is a 17-year-old entering an electronics and communication engineering program, and he had what we might call the education illusion. He believed something so simple, so innocent really. He figured, hey, if I just study sincerely, complete my exams, and trust my professors, the system is just going to naturally mold me into a competent engineer. And, it's a completely understandable mindset for a teenager, right? He trusted the system totally. He didn't even know what he was supposed to be asking for, because he was just a student, not some seasoned engineer.
But of course, reality is rarely ever that smooth. Now, what's so refreshing about Gobal's account is his absolute, unfiltered honesty about his academic record. He doesn't hide it, he doesn't dress it up. He started the program in 2012, but he actually didn't graduate with his original class. He had what are known as arrears, basically failing grades in these super heady theory subjects like computer architecture. That forced him to retake exams and literally delayed his graduation by a full year. He did eventually clear them and graduated in 2017 with a 7.55 CGPA. But listen, this kind of academic struggle, it is a silent reality for millions of students all over the world, yet it's almost never talked about with this kind of neutral transparency.
And a huge part of that struggle comes from what students are actually expected to digest. Just look at the sheer volume of stuff packed into an engineering curriculum. We're talking mathematics, signals and systems, VLSI design, microprocessors, electromagnetic fields, antennas. The list just goes on and on. It is incredibly, overwhelmingly dense. And this density, it creates a really dangerous illusion, the illusion of learning. It kind of tricks you into feeling like, well, because I'm drowning in all this complex information, I must actually be learning how to swim. But here is the crucial realization that Gobal finally hit upon, and honestly, it cuts right to the absolute heart of our explainer today. A syllabus is simply not the same thing as an education. Just having digital signal processing printed on a piece of paper does not automatically mean a student can practically implement it. It doesn't mean they can test it, and it definitely doesn't mean they truly get it. The system treats covering the syllabus as basically providing an education, but those are two vastly, vastly different things in the real world. Now, what's really interesting about this is looking at how a genuine, curiosity-driven engineering project should actually break down. This right here is the antidote to just blindly memorizing a syllabus. A real engineering experience teaches you problem identification. It forces you into the weeds with rigorous mathematical analysis. It actually requires hardware or software implementation, which you then follow up with testing, validation, and, maybe most importantly, failure analysis. This whole step-by-step process is just insanely valuable because it's how you actually map theory to reality. But when it finally came time for Gobal's final year project, the one thing that should have actually encapsulated all those ideal steps, the harsh reality of the system just set in. He openly admits that the college environment essentially pushed students toward these outside project centers. Ultimately, he basically just bought his final year project, instead of independently developing and building the whole shebang himself. Think about that. The system literally incentivized a financial transaction over genuine learning. It completely deprived him of that hands-on process that actually bridges the gap between a dusty textbook and a functioning piece of technology. So years go by after graduation, and Gobal experienced something that, let's be real, almost every single graduate goes through. He forgot so many of the concepts he'd studied. At first, he said this felt like a massive personal failure, but as he sat with it, it led to this painful yet totally necessary awakening. He started asking himself a really heavy question. Did he actually understand these subjects deeply, or did he merely learn just enough to pass the test? It's a profound realization. It forces you to confront the difference between genuinely retaining knowledge and just kind of temporarily borrowing it for an exam. Which brings us to a really stark contrast. There is a massive fundamental difference between learning just to pass an exam and learning so deeply that you can actually use that knowledge years later to build something real. This contrast is the absolute core of why engineering degrees miss reality. The entire university apparatus, I'm talking the lectures, the assignments, the nonstop stress, it's all almost exclusively optimized just for the exam. But reality, industry, and genuine innovation, they strictly require deep foundational understanding. No way around it.
But here is where the story takes a massive shift. Years after college, his true education actually began. He just exploded into these highly advanced self-taught interests in computing. We're talking CUDA, ray tracing, neural networks, GPU computing, engineering simulation. And the kicker? He wasn't studying these for some university exam. Nobody was forcing him to learn optical simulation. Nobody was handing out marks or a degree for understanding AI. He was diving headfirst into these incredibly complex topics purely out of genuine, burning curiosity. And because his motivation completely changed, the way he learned changed right along with it. He stopped asking, okay, what's the answer for the test? And he started asking the real foundational questions of reality. Like, why does this equation actually work? Can I derive it myself? Can I simulate it on a computer? How do I validate this result and actually prove it's true? This shift in questioning is absolutely monumental. It transforms engineering from this boring memory exercise into a dynamic, active exploration of how the universe literally functions. Yet, as Gabal went through this totally self-directed awakening, he couldn't help but look back at the system that was supposed to teach him all this in the first place. And we've got to address the elephant in the room here regarding a university's responsibility. An 18-year-old kid walking into college doesn't naturally know how to validate a simulation or pick a research problem. I mean, that is literally why education exists, right? So, did the system actually give students the opportunities it promised? Well, to answer that fairly, Gabal notes we really have to look objectively at the evidence, the university regulations, faculty records, the actual laboratory facilities versus what was promised, and the project guidelines. Which brings us to a pretty profound conclusion he reached about evaluating his own past. Truth requires evidence. Evaluating an education system, or even just looking back at your own past mistakes, shouldn't be done with sweeping anger or wild assumptions. It requires a neutral, honest look at the cold, hard facts. He couldn't just say his college was entirely bad, nor could he say every single year was completely wasted, because hey, his own decisions and mistakes played a part too. Finding the truth means accepting all the variables objectively. So what do you do when you finally realize your degree missed reality? Well, you take control. Sure, you can't build a time machine and go back to 2012, but you absolutely can change what happens next. Gobal's next steps here are incredibly empowering. Rebuild the forgotten knowledge. Actually build a ray tracer completely from scratch. Study numerical methods. Run experiments. Validate those results. And meticulously document every single thing. You stop waiting for a professor to hand you a syllabus, and you just start building your own curriculum based on genuine understanding. And this brilliantly illustrates the exact mindset required to do this successfully. Gabal established some seriously powerful guiding principles for rebuilding his engineering foundation from scratch. Truth before ego, evidence before accusation, learning before pride, and validation before assumption. He totally acknowledges he doesn't know everything, and yeah, he may have lost some years, but he hasn't lost the ability to learn. And more importantly, he hasn't lost the ability to ask the right questions. Which leaves us with one final provocative question to wrap up this explainer. Looking back at your own journey, did the system fail you? Or is it simply time to start your real education today? You might have the pieces of paper that say you're educated, but genuine understanding is something you have to go out and claim for yourself. The past cannot be rewritten, for sure, but today can always be the beginning of something totally new. Thank you so much for joining me on this explainer, and I really hope it sparks some curiosity for you to start learning for truth rather than just for a test.